You've seen how derive was used to obtain a matrix of population figures. If we start with 1,000 sane and 0 demented using the same transition matrix, A equals the usual matrix here, we obtain these numbers of sane and demented using the same types of techniques. We could do these by hand also, but we let derive do the work here. Now if we plot the population vectors corresponding to these numbers, and here's what I mean by the population vectors. 1,000 0 means 1,000 sane, 0 demented. 800 200, 800 sane, 200 demented. And 660, 340, and so forth. And you really should sit down with a piece of paper, hopefully even a piece of graph paper, and make a plot of this sort of thing. Now, the question is, what shape do these lines make? And also, how do they approach the limiting population, the limit point of this sequence? We see, if we do these carefully, that the vectors keep getting closer and closer together, and we know they approach some limiting value, which is 333 1/3, 666 2/3. I've drawn that over here a little further than it really belongs, just to emphasize that we're approaching a limit point, and there might still be a lot of stuff in between here. But in any event, we do approach this limit point. Is this a straight line? Is it maybe an arc of a circle that I haven't drawn very well? Is it part of an ellipse, a parabola of some sort? Just what is it? Well, we can answer that question fairly easily. Since S plus D is 1,000, it turns out that D has to equal 1,000 minus S. Whatever the demented population is, it has to be 1,000 minus the sane population. Now, if this was y versus x, it'd be y equals 1,000 minus x, and we'd immediately recognize that as a y equals mx plus b straight line with a slope of -1 and y-intercept b equals 1,000. Now, it's not x and y, it's d and s, but slope of -1 and a y-intercept of 1,000, yeah, that's what this line would have to do. Of course, these points are never going to reach that y-intercept, but if the line was extended, it would have a y-intercept of 1,000. So it's kind of interesting that we get the kind of results that we do here.